So now we're on to the last section, which is the section of energy sources of tomorrow. The first energy source we're going to talk about is the solar power plants, and then also look at, the solar farm, which is one of the pictures that we saw in the last unit. Solar power plants uses photovoltaic cells that span a large area, and these cells convert solar energy to electricity. And as you can see in the picture, these cells made up in panels, and the panels all point in a direction to maximize the exposure to the sun. And these panels have these semiconductors such as silicon and gallium. And when light hits on these photovoltaic cells, the light knocks off the electrons from the atoms in them, and then the cells help them to move those electrons in one direction, and that creates a current. The other energy we're going to talk about is wind energy. And we get wind energy, or wind energy is used to produce electricity through a wind generator. So the radiant energy from the sun heats up the earth, it causes a pressure difference, and that's how we get our wind. The wind energy accounts for about 6% of the United States of America's energy production. And in certain geographic limitations that exist, for example, wind energy needs to have a wide open space with a constant source of wind, which if you've driven through the middle of the country around Kansas and Oklahoma, you may start seeing some of these wind turbines. One of the other limitations to wind energy is the fact that it can hurt wildlife, as birds can fly into the windmill, and also those living close to the windmill can hear the noise or the whirring sounds of the windmill. So we've looked at hydroelectricity, and we've looked at generation of energy or electricity from the nuclear power plants. So let's look at what is happening with this generator. So wind blows past the turbines and on their rotating blades, and the wind blows on the blades, have them rotate, so that kinetic energy as the blade is turning is transformed to mechanical energy, because there's a gearbox in the back of that fan, which is spins a generator. And of course, the generator is kind of like a small turbine. You can think about that with the electrical wires and the magnet field or magnetic field close in contact. And then you have the electricity. So each of these little boxes or each of these windmills will have its own energy. And then that is sent to a substation where the transformer converts electricity to the appropriate voltage, and then it's sent to the grid for distribution. Next, we have biomass. Biomass is from organic waste that could be otherwise used as landfill or burnt. Now, it can be this biomass can be burned directly as fuel and converted to gas fuel, like methane, or converted into liquid fuel, like alcohol. There are currently 178 biomass power plants that produce about 6,000 megawatts of power in the United States. So here's what you have with a biomass. Again, the goal of these things are ultimately to produce electricity. So we have the fuel, which consists of all the organic waste, and this is burnt, and it's being burned here. So as you get this biomass trash. And above that, you have a water supply. This water, because of the energy from burning that or combusting that, converts that water to steam. That steam is used to at high pressure to turn the turbine, which is connected to the generator. And again, that produces electricity as it's sent to a station where the transformer increases it to the correct voltage and then sent to distribution into the grid. So regardless of what the source is for the steam or the water, even if it's wind, the whole goal there is to turn these turbines that's connected to generators, and that's going to produce our electricity. So it's not directly that the organic waste is directly producing energy, but the fact that burning them is used to create the steam that can turn the turbines. The last one we're going to look at is called ocean thermal energy conversion, OTEC. And this makes use of the temperature difference in the ocean from water temperature at the surface to the difference between the surface and water temperature in the deep waters. And then ammonia, which has a low boiling point, is used as a fluid to evaporate and turn the turbine. So far we've seen that water is what's used, the steam from water is used to turn the turbines. With OTEC, ammonia is used to turn the turbines. So what you have is you have warmer seawater at the surface and colder water at deeper below. And in the channel, you'll have, because of the warm water, you can have ammonia being converted to a gas, and that's pressurized, and that goes to turn the turbine. Then the ammonia goes, and because of the cold seawater, it converts back to liquid ammonia and then pumped back into the evaporator where it goes up to the surface of the liquid. So that's the end of the different types of energy sources that we have, and that's the end of chapter 3. And thank you for listening. Then we have geothermal energy. Geothermal energy uses a heat from deep within the earth to produce steam, and it uses heat closer to the earth's surface that can obtain heat for keeping hot water systems in homes and buildings, and even for indoor heating. So we have our OTEC, and just excuse me, I said we were done, but we still have this geothermal energy to be done. And so again, just like the OTEC, we have hot water from the surface, because that's where the heat comes up from these systems deep in the Earth's surface. And that hot water then is used to convert to steam, to turn the turbines and generate power. And if there's some closer to the surface energy, that's used to actually heat homes and buildings. And this is definitely the last one. It's a hydrogen power. Notes that we can talk about with hydrogen fuel is that it produces no pollutants at all. It's not quite abundantly available on the earth. So it's extracted from chemical reaction. And funny enough, it's from the decomposition of water that gives us hydrogen and oxygen. So it's very clean. And what happens is when we have hydrogen sitting at the anode, that hydrogen breaks down into an electron and a proton. The electrons are collected by a conductive current collector, and that is connected to the voltage circuitry, for example, in the car. And that's how you get the electricity in the car. So you break down water, you get the hydrogen, and then the hydrogen at the anode from the breakdown of water breaks down further into an electron and a proton, and the electrons are what's used to conduct electricity. All right, so that is the end of chapter 3 officially, and thank you for listening.